going to be looking at data cleaning as the course here in Kaggle. If you click on that, you're going to see a series of 5 lessons, and you can click on the first tutorial and open that up in your Kaggle account. What will happen is you'll reach something like this. I've done this in my own account. So diving straight into data cleaning, as I mentioned, this is really like one of the most important sections in this whole course because, yeah, of course, you're going to run across data sets that have lots and lots of problems of missing data and all kinds of things. And today we're going to talk about missing data, missing values. This is really like one of the most obvious common things that happens. And Pandas has a few ways of identifying missing data and remedying that situation. So in this particular notebook, you've got a chunk of code here, which is going to load a test data set from Kaggle, which is National Football League, American football games, a data set which has a whole bunch of examples of, so during American football games, you have lots and lots of plays where the ball is moved for a play, and then once somebody's tackled, that's the end of the play. So there's a beginning and end to a play. And this data set is that type of data. So since we've loaded that data set, we can first take a look at the first 5 rows using the .head function here. And the question that's being asked here, is there any missing data? And we can see very quickly in the first row for this column called down, you have NaN. Over here in this column, YAC EPA, there's an NaN on 3 out of the 5 that we can see right here. This particular data set has over 100 columns. We're seeing the first 5 rows here, and we're already seeing some missing data. So the question that you might want to ask yourself is, how much data are we missing here? And if you can do that, you can see that by using the .isNull function here, and which is going to go through each of the columns and figure out how many, basically it's going to identify how many points are null or NaN. It's going to sum those across the columns. There's 100 columns, so we're just gonna look at the top 10 columns, the first 10 columns, to see how many are empty or not a number. And some of the columns here have 0 missing values. The first 4 columns have 0 missing values. Then you have this column down, time, seconds, play time differential, side of field. You have quite a few missing values in each of those columns. So you want to maybe figure out, okay, what is the total percentage of missing values in this data set? This is a chunk of code which is going to give you the total number of cells, the total missing cells, and then you just divide one by the other, multiply by 100, and you're getting close to 25%, close to a quarter of all of the data in this data set is NaN. So that's quite a bit of data. And one of the things that you do at this situation is you're going to try to figure out why you think that data is missing. And there's 2 main reasons that data is missing. First one is that the data wasn't recorded. There's some sort of problem. The person who was keeping track of that just wasn't paying attention to that particular part, didn't write it down. Or the other side, it just doesn't exist. You have to also ask yourself in a certain column whether it's possible that particular column just doesn't exist for that particular situation. And you have to figure out, okay, what are you going to do? And in these 2 situations, it depends on which one it is about what you're going to do. So if we look again at the missing values in the top 10 columns, the story here is that they're basically asking you to try to figure out maybe quickly how you can fill these NaNs or remedy them. Because, yeah, a lot of times you're going to need only the complete rows in order to make visualizations, to do different types of data analysis. One of the first things you can do is there's a very quick and dirty function called drop NA. Drop NA literally just like removes any row that has at least 1 missing value, which is it's not something that you want to do very often. It depends on the situation, but a lot of times missing data is something you can fix and not just get rid of the rows that have missing data. In fact, in this data set, if you get rid of every row that has at least 1 NaN, you end up with 0 data. It removed all the data. Maybe you're only concerned about dropping data from columns that are maybe have a certain percent level of importance to you. On the other hand, you just want to drop columns that have 1 missing value instead of rows that have 1 missing value at least. So if you do that, if you drop every column that has at least one missing value, what you end up with is a data frame with 41 columns out of 102 columns. Out of those 102 columns, 41 of them have every single value possible. And the question is, okay, how much data did we just lose by cutting out all those columns? We had 102 originally, now we only have 41 left. So that's quite a bit of missing data. So here we have a subset of data, of the NFL data, where we're pulling out columns that have basically EPA through season. So it's a subset of the columns. We're looking at the first 5 rows here. And one of the things we can do is use fill, a function called fill_NA. Fill_NA, whatever you put inside that, every NaN will be converted to that. These particular columns that were pulled out are statistics that if maybe it makes sense to fill those with 0. Another way of filling is something called fill_NA, and then you can use attributes or methods such as bfill. There's another one called ffill, so backfill and forward fill. Backfill and forward fill essentially will take the value that comes directly before that NaN and fill it down or up based on whether you put backfill or forward fill. And then whatever's left, you could use fill_NA 0. So in this case, it's a little more complex. And so fill_NA has a few other attributes, which you'll learn about if you check out the exercises, or you could just look at the documentation as well.